All right, so 3.8 part 2 hand in. I got it right here. I got answers we're looking for. So it's all based on this data. So what I'm going to do is I'm just going to copy this over. I'm going to select it. I'm going to go copy. I'm going to do it in a spreadsheet. This is basically all the information we're putting in. So I'll paste these in and move some stuff around. Move this over. Okay, give myself a little more room here. So let's see. We're doing this. This is the accepted value right here. So I'm going to copy that over. And I'm just going to highlight these to make them super apparent. Now all of this stuff, I don't want the cells formatted in any way, so I'm going to remove the borders. And first thing I'm going to do for each of these is I'm going to just do a data sort. Like so. So I'm just going to do data sort on both of them to get them in order. Now, it's asking us some information here. So first thing it's asking us is, what is the mean of each caliper? Okay, so that's pretty easy. I'm going to go right here. I'm going to do mean equals, this is going to be for my z-score later. So I'll add z-score in here. My mean equals average for this range. So there's my mean. And I will do the same thing over here. I got mean, which equals the average of this range. So these are my two averages. And you can see that this average appears to be closer to our accepted value. So this data set is more accurate than this data set. Okay. What is the sample standard deviation for each? So standard deviation sample, let's do this, equals standard deviation for the sample. Select that, and we're going to come over here, and we're going to do the same formula over here. So there's the sample, and you can see that the standard deviation for this one is smaller, meaning this one is also more precise. So using the error, provide an answer to justify which caliper is more accurate. So I'm going to do error measurement for both of these. So this equals our mean minus our accepted value. And this equals our mean minus our accepted value. And as you can see, this is a smaller number than this. The negatives are inconsequential. So this is the better one for that answer. So that would obviously be there. So now I got to make a statement about caliper 1 at 90% confidence. So 2 standard deviations from the mean. Okay. So I'm going to do my z-score here, which is our value minus, and we're going to use the accepted value instead of the mean. Oh, no, it says from the mean, so we're going to use the mean. So we're going to do it from the mean. And we're going to divide that by the standard deviation by the sample. We're going to put our dollar signs in there, very important. And we're going to drag that. So there's that data set. We're going to do the same thing over here. Equals R value, parentheses, very important, parentheses, R value minus the mean divided by the standard deviation. No, standard deviation. There we go. Dollar signs all around. And we're going to drag it. Okay. Now, I'm going to do me some conditional formatting on both of these ranges. I hold Control to select them both at once. I'm going to go to Format, Conditional Formatting. And if it is between 1 and -1, I'm going to make that yellow. And then I'm going to add another rule. And if it is between 2 and -2, I'm going to make that green. Okay. So, some quick counting. So right now I've got a count of 25. So that's a count of 25. 24 out of my 25 are within 2 standard deviations. So when it is asking me, make a statement about caliper 1 at the 95% confidence level, 2 deviations from the mean. So if I do that, if I say equals 24 divided by 25 times 100 for percentage, 96% of my values fall within there. So I'd say I have high confidence in this data based on what I have here. You could also, as I did in this sheet, do a low value and a high value for your standard deviations. So if I low value and high value, I could say one standard deviation in this row and 2 standard deviations in this row, and I could say low value equals obviously the mean minus the standard deviation and the mean plus the standard deviation, and then oops, and on the bottom I could do the same thing, mean minus minus, and then I could also go equals mean plus plus, and I could look for 2 standard deviations and see, okay, so all the values starting down here, so that'd be here, it'd start here, and I already sorted this to 1.18, so it's starting there, it's going to 1.4, so it goes there. So from here to here I could do it, and it gives me my count of 24 out of 25 anyway. So either way you want to do it is acceptable. I like the z-score, I just think it's faster. That's me, and you don't got to figure this stuff out. But it's important to know it if you were asked. So what other questions we got on here? It says make a statement about caliper 2 at 68%. So once again, if you wanted to, you could go in and you could do this low and high value thing. So you could do this kind of thing again and just change the letters. Change them from I Oops. It actually copied everything over. So that worked totally proportionally. So I was able to copy it. So we could do it this way, and 68 would be here, one standard deviation. So I could look for everything that falls between here and 1.339, 1.33 here. So I could do it and look for everything fall between here and here, which is 22 out of 25. So it equals 22 divided by 25 times 100. At 88%, I would say I have high confidence in that because that is greater than 68%, so that's real good. Or I could have just looked at the z-scores, which I think is faster, but that's just me. So this is basically everything you got to do. Based on the data above, which caliper is more precise? And I'd say caliper 2. You do not have to do this. You paste the Excel work. You don't have to do this, but you could make a histogram if you wanted to with bins and everything. Not requiring that for this one, but for the next assignment I will. So hopefully this answers any questions for anyone who is struggling.